Welcome you all. If we revise what we have discussed earlier, we have discussed the hydrological cycle of water, then we discussed different properties of water, then we discussed the concepts of your biological and physical classification of water, then we discussed different concepts of water potential, then we discussed the concepts of different availability of water to plants or roots, we can say. Now we shall discuss about different measurement methods of this soil water. If we broadly see, I have divided them into two groups: indirect methods and indirect methods. Indirect methods, if we see, there are some methods used like thermogravimetry, your alcohol burning method, your calcium carbide method. If you see, first we will discuss each one. Now if you see thermogravimetric method, what we do actually, we take the soil sample from field, this moist soil, we will dry that in oven. Okay, normally we keep it oven for 24 hours at temperature value of 105 degrees. So the oven, after oven drying, the water will be evaporated. Now if you want to calculate the water content, this is a very simple way. You can say the moist weight, while you collected the samples, that weight only, moist weight, we will take it in aluminum foil. Later we will subtract that aluminum weight also. Moist weight minus oven dry weight divided by your oven dry weight. This is very simple method of actually your calculation of soil water, and these direct methods give absolute value of your water content. Now coming to alcohol burning method, this is also a very simple method. What we do, normally like spirit or alcohol along with soil water is burned, so that it will be evaporated. So we will calculate earlier what the water content may be, and the amount of water evaporated, we will subtract that, we will calculate the water content by this method. Okay, these methods are very less popular. Why we will see. Now if you see calcium carbide method, here what we do, we simply take calcium carbide, the calcium carbide will react with the soil water, this will form acetylene. Okay, and this acetylene content is, we can say, directly proportional to the amount of water present. Okay, although these methods are very simple and give absolute value, we don't normally use these methods. Why? Because this is a destructive method. Earlier I have told also that soil samples are taken from field. So this is a very destructive method, and we do it normally in our lab. So why? What are the memories? Then you can write it is a destructive method. And another point, if you see, for analysis of this thermogravimetric method or any direct method, we have analyzed the soil sample. Now the soil sample is left. So for periodic or regular measurements, we have to take large volume of soil sample. You got my point? So large volume of sample is required. So you see, we require large volume of soil samples, and also it is a destructive method. So therefore, we most often go for these indirect methods. And also another point, we measure all these methods. Why? To irrigate this, to schedule the irrigation. So irrigation scheduling is our main aim. So if we will do that in our normal field condition, that will be better. So these indirect methods are actually used in your field conditions, and these are non-destructive. Can say these are the non-destructive. So that's why we choose these indirect methods. So if you see the principle, this is we'll discuss one by one. In a broad way, if we see what is the principle, then the working of these indirect methods. We can say there are different properties we have discussed, like your dielectric constant, your electrical conductivity of water. This will provide in opposite to resistance. So all these properties will equilibrate with the soil water content. That way we will measure the soil water content. Now discuss each one of them. We will discuss each one of these methods individually. These methods are neutronmoisturemeter method, NMM for short form, gamma ray attenuation method, electrical resistance method. Now we will discuss each one of them individually. If you see this neutron moisture method first, so we are talking about neutrons. So neutrons are what? These are the fast moving. We can say neutrons move very fast, and they have a weight or mass. We can say these are nearly similar to your hydrogen mass. We'll see. I have already told, to understand more of the concepts, we'll draw some diagram. If you draw the diagram of the neutron moisture meter, this is a, you can say, neutron moisture meter. Okay, and it is actually where the reading comes. You can say it is scalar. And this neutron moisture meter mainly has two components. One is your scalar, another one is your probe. There will be, in this probe, there will be detector. And another source will be there that will produce fast neutrons. This is a probe. Okay, very simple. And this probe is connected to this color to a aluminium access tube. This is a cable, or you can say this is the aluminium tube, and this is your cable. Very simple. Now, if you see, we will see all these principles in step by step. First, in first step, this source, this is the source. So from here only the fast neutrons will origin. So you use normally americium and beryllium. Okay, these americium having mass of 241 and 95 your proton number. This will give your neptunium plus alpha particle neutrons. Okay, this is your alpha particle, and the source is made up of one is americium, another one is your beryllium. This beryllium is actually the stable one. This is unstable one. This is the stable one. So this will react with your alpha particle and produce your fast moving neutrons. In this process carbon is produced, but our main aim is to produce this fast moving neutron. This is your neutron, you can see having mass number 1, proton number 0. So this is fast moving neutron. Why it is fast moving? It acquires energy of almost 2 to 3 mega electron volt. Okay, this much energy it acquires. And we can say acquiring this much energy, it moves with the speed of almost 1600 km per second. You can see such high speed. So we can say this is the fast moving neutrons. Now this from source, now these are the fast moving sources are produced. So these will be collided with different atoms of hydrogen, your carbon, oxygen are available in soil. So this will collide with them, and after collision, this will again return to your detector. After collision happens, this will be returned to your detector. Consider these are the atoms. These are collided and returning to your detector. So this will form like a sphere. We can say this is a sphere of thermalized neutrons. Sphere of, these are the thermalized neutrons. So what is the process of what is thermalization? Some thermalization you have to understand. This is very simple. The speed is actually reduced. Okay. So thermalized neutrons means earlier you are having very high speed, and later after collision with other nuclei it becomes thermalized and reduces speed or energy. Now, if you see in terms of your hydrogen atom, if we collide with the hydrogen atom, it reduced its speed to almost 0.03 mega electron volt. This much of speed energy reduced. Now, why we consider hydrogen atoms only now? That because the neutrons, we have seen first neutrons, the mass is nearly equivalent to the hydrogen atom. Hydrogen atom is available in your different isotope forms: protium, deuterium, tritium. Like this way, there are different isotopes available. But you consider this fast-moving neutron source which collide mainly with this protium atom, okay, hydrogen atom. This will equilibrate with the soil water content, and to detect this hydrogen atom, we normally use the reflector, which is made up of your boron trichloride. Try to understand and just remember this memory based also things. This BFP is your detector. So how will it detect? You see the chemical reaction. Okay. Sorry, boron trichloride. Okay, this boron trichloride, this boron, only boron I will see for reaction. This boron have a atomic number of 5 and mass number of 10. So this will detect when the neutrons are detected. The reaction will be again produce this alpha particle and your lithium. Okay. Now this boron trichloride actually detects the moving neutrons, thermalized neutrons. Sorry, these are the thermalized neutrons. Thermalized neutrons. So we can now see these thermalized neutrons are more in number in this sphere of radius. This sphere of radius may vary actually. This sphere of radius may vary up to 15 centimeters in your dry soil and up to 10 centimeters in your moist soil. Now we have discussed one component. If we see what is the role of this scalar then, or scalar, or we can say this is the rate count meter. This is the rate count meter. After the detector detects how much of thermalized neutrons are there, this will be read by this scalar. This will be shown to us. You can see this is the soil surface. This part is actually upper, and this part is inserted inside the soil. We can see here the reading how much of your fast moving neutrons are thermalized. So this fast moving neutrons which are thermalized is directly proportional or you can say equilibrate with your soil water content. Very simple. Now you got my point. These thermalized neutron atoms, or we can say presence of these hydrogen atoms, we consider the thermalized neutrons are mostly because of collision with hydrogen atoms. So this collided hydrogen atoms is, can say, directly proportional to the soil water content. This is very simple. Now you got my point. What is neutronmoisturemeter? Now if you see, what are the advantages there? Every method you are using have some advantages and disadvantages. What are the advantages now of using this neutronmoisturemeter? Advantages are, this is non-destructive. First point we have told, and you can say this is regular periodic measurements can be taken. Okay, non-destructive. Regular periodic measurements can be taken. And the measurement is on field condition, so it will be, your irrigation scheduling will be easier. But what are the disadvantages? Main disadvantage you say we are using this americium, beryllium. These are the radiation sources. So this may escape to the surface and may create the health hazard among us. This may create the health hazard. These radiations may cause your health hazard. This is the first you can say major disadvantage. Another one is your initial investment cost is very high. Initial cost is high, and to use this meter also or method also, we can say high expertise is required. So these are the some advantages we can say. Now coming to the another method, which is your, what we will discuss. Second method we will discuss about gamma ray attenuation technique. So from name itself you know the radiation sources used are mainly what? Gamma rays. In gamma ray attenuation method, the gamma ray attenuation this actually you can see, we'll see this actually having two components also. One is your source which will produce the gamma rays. Okay, and if you think this is a soil column, there will be solids, liquids, like this. This soil column. This is one part. Another part is connected to your detector. Okay, this is, you can say, source. What will source produce? The gamma ray from cesium. To take normally cesium 137. Okay, this is the source of your. This is the source will detect the water content, and in detector we take normally what? If you say this radiation is coming, this will, if this is dry soil, just think this is very dry soil. Okay, water content is there. And if you think normally soil, there will be some radiations will be absorbed, some will be scattered. Okay, some will be activated. Okay, some activated, when some activated rays reach the detector, we will detect how much of soil water is there. This is very simple way. And in detector we normally take helium activated sodium iodide crystal. These things you must remember. You can see we have by this figure we can visualize how this method works. But we have to remember these radiation sources, what are the detector. Okay, this is bound. We have to remember. Okay. Now, if you see the gamma rays are produced, this will pass to the soil column and some will scatter and some will get absorbed. So after activation, these are reaching this sensitive probe, or you can say helium activated sodium iodide crystal detector. Now, if the ball density remain constant and any change in water content is there, then the attenuation will be reduced. So that way we will measure the amount of soil water content present in your soil column. Okay, this is very simple. If you see the relationship in mathematical terms, we have to calculate ultimately the soil water content. So mathematical relationships are also important. Can say NW by ND is equals to your exponential component of volumetric water content. Another one is your attenuation coefficient and your thickness. This you must remember. Here, if you ask what is NW, this is the when this cesium radiation is passing, okay, the flux that created in wet soil, flux of radiation at your wet soil. And ND, you can guess what is this flux of radiation that is passing through your dry soil. Flux of radiation passing through your dry soil. Write down and dictated here. And if you see, this theta is your volumetric water content. Volumetric water content. We have discussed volumetric water content all this in detail. You may now can very well grasp. This is the attenuation coefficient of water. We are talking about that attenuation now. So this is the attenuation coefficient. And H is your thickness of the medium. And if you observe, this actually resembles your Beer's law. This actually resembles your Beer's law. Some might be knowing also Beer's law, where it will be used during spectrophotometry calculation of essential nutrient like your phosphorus. What we do here is in spectrometer we take a concentration. Okay, when a beam of monochromatic light passes through that concentration, the intensity of radiation decreases. Minus di by dc is proportional to I. So this type of relation we will discuss later in your analytical chemistry, or you may go through that. In Beer's law, simply you can say the more the concentration, the intensity will be reduced. Like that way. That way only we can see this relationship is resembles to your Beer's law. Now coming to your another method, which is your electrical resistance method. From this electrical resistance method, you might getting a point. We use electricity. Electrical resistance method means we use. And I forgot to tell one thing. You just remember that gamma ray attenuation method was given by Van Havel. Okay, gamma ray attenuation method was given by Van Havel. This type of memory-based question may be asked Van Havel in 1957. In the year 1957. Okay. Now this electrical resistance method actually given by Boykus and Meek. This was proposed by Boykus and MIG in 1940. What happens actually, if you see the electrical resistance meter, this is actually you can say instrument, and this is the cable where there will be battery will be connected. From this battery you can say two electrodes are there. They are connected to your a porous medium. If we can say this is a ER block. If you draw this in macroscopic level to understand the principle how it works, you can say this is your electrode which is embedded in a porous medium. Okay, and these electrodes are connected to a Wheatstone bridge. This is your Wheatstone bridge. We have studied this in our 12th also. How Wheatstone bridge works, how this electricity, this galvanometer, all these things. Wheatstone bridge, AC Wheatstone bridge you can say. These are the electrodes. And this is your porous medium. Porous medium may be your made up of may be gypsum, may be your nylon, may be fiberglass. So all these units we can say electrical resistance block. Now from this figure you may get the idea now. What we do, we actually through this battery will produce the electricity. The electricity will pass through this porous medium to the soil. Okay, if we know water is a good conductor of electricity. If the more the water content, then there will be more electrical conductivity. If the water content is reduced, then the more resistance develops. Simply as the soil water content decreases, more electrical resistance is produced. That way, actually, we measure this soil water in this electrical resistance method. That this is the main principle. Simple way we can say we can measure the soil water content. So there are also during producing this electricity, these are affected by many factors in soil, like your hysteresis we have discussed. What are the factors now affect? Okay, during these readings, like your hysteresis. Another you can say factor like hydraulic property of this block, hydraulic property of block. And another important point which is affect this is salinity. Okay, this is also one of the major factors which affect the your resistance reading. And from soil to soil we have also to calibrate this meter, because your water content, all these things change, so you have to calibrate it. And we see the resistance readings. This resistance readings for your field capacity moisture content, we can say 400 to 600 ohms. We can see this is the Wheatstone bridge. By through this we can measure the readings, and this will be shown in your probe. And another reading at wilting point, the readings come 50,000 to 70,000 ohms. These type of resistance readings come. And another thing you can say, this if you discuss about this porous medium, we can say this may be made up of gypsum, may be nylon, may be fiberglass. We see the working conditions. This nylon glass actually may work up to 1 to 15 bar. Okay, this range, this can work, and this fiberglass also, sorry, nylon blocks normally work less than 2 atmosphere. Less than 2 atmosphere. Remember, this works less than 2 atmosphere, and your fiberglass works up to 1/3 to 15 bar tension. Soil water tension we have discussed. Instead of soil water potential, we can say rather it measures the soil water potential also. Okay, we have written your soil water content. You can rather say it equilibrates with your soil water potential. Okay, soil water potential. Just try to understand here and remember these points, because this is not very much in your use. So to remember these points, this is very difficult. And gypsum block may work up to 1 to 15 bar. Normally we use this gypsum as porous medium. Why? Because the calcium sulfate, as you have seen, the salinity problem is mainly affected. Salinity affects the reading of this meter. So this gypsum produces calcium sulfate. This will be neutralized. This will neutralize the salinity to some extent, and this will be easier for us to take the readings. Now we have read the full concept of electrical resistance. Okay, and if you see the advantages, this is a cheap method. We can see very less costly. This method can be used and can be embedded at any depth. But disadvantages I have discussed. Okay. Now coming to the other method, which is your TDR, time domain reflectometer. Time domain reflectometer. So this TDR, fourth method we are discussing. This time domain reflectometer. Let's also draw this diagram, conceptual diagram. This is, you think, a probe. This is connected to a wire, and this is your measuring. This is your probe, TDR probe, and this is your cable, which will produce electromagnetic pulse. Okay, and this is your reading. So what happens? This probe will generate to this cable the electromagnetic pulse. This electromagnetic pulse will travel to the soil and will collide with your dry soil, your moist soil, or more quantity of water. So this method actually measures soil water content with the principle of dielectric constant of water. Dielectric constant. We have discussed what is dielectric constant. Due to hydrogen bonding in water, the dielectric constant property is mainly developed. So, if you see the dielectric constant value of a dry soil, this value mainly comes up to 3 to 6, and in moist soil it is in range of 20 to 30. But in case of your wet soil, rather we can say soil water content is more, then the dielectric constant value increases, this reach up to 80. So in this way, the electromagnetic pulse which radiates to your detector, we can measure if the soil is more water content, the more electromagnetic pulse will be reflected. This will show more resistance. That way, if you see a mathematical relationship here also, to see a mathematical relationship here, you can express it as CA equals to CL divided by CT divided by 2L whole square. What is Ka? This is the dielectric constant of water. This is your dielectric constant of water. Okay, this C is your electromagnetic pulse speed. Electromagnetic, we are talking about electromagnetic, that means this is the speed of light. Okay, this C is your speed of light. You can say the speed of electromagnetic pulse, or you can say speed of light, 3 into 10 to the power 8. You know that speed of light. And if you see this T, what is this T? This is the time travel. Here, think this is the electromagnetic pulse. This is your water molecule. From this, here it will collide and return to your detector. Okay. This is detector. Actually, this instrument is your buried inside the soil. Okay. So the detector, this reading is detected. So the time it takes from this electromagnetic pulse to this detector, this will be given by T. L means the distance is travels. The electromagnetic pulse, the distance travel is given by your L. This is very simple. Just remember this mathematical equation so that you can explain this principle. Now, if you see the advantages of this TDR meter, this actually your neglects all the texture independent of, you can say that it is independent of texture as well as temperature. There will be different textures, there will be different temperatures from soil to soil, that will vary. Here it will independent of that. Now coming to another method, which one is your microwave remote sensing. The name remote sensing itself, you know what will you use there? Electromagnetic radiations. And if you using that, if you are using your microwave radiation, there are many kind of wavelengths, you know, like your from X-ray, UV ray to your visible region to IR, and your microwave, radio wave, like that. So here for soil moisture content determination, we normally use microwave remote sensing. You will ask why microwave remote sensing then? We will see the process. If this is an active sensor, what will you do? This is your soil surface. This is your water body. This is plant. Vegetation is there. So what will you do? It will send some EMR. And this will be reflected to again the sensor to read it. Okay. We using the microwave remote sensing, the major advantage is if you are using less wavelength remote sensing waves, then it will be you are affected by cloudy conditions. More vegetation is there, that will be also affected. But if you use microwave remote sensing, this is also used mainly in case of military purpose also, microwave remote sensing. So IR microwave remote sensing, all these are. This will neglect the effect of your cloud, and if more vegetation is also there, this will also be not affected by this microwave remote sensing. That's why we choose microwave remote sensing. So what we do? We know when the radiation comes to the surface of Earth, some will be absorbed, some will be reflected, some will be scattered. This reflected wavelength, or we can say here back scattered radiation is actually the main source by which we will measure the soil water content. Just try to remember and understand here. This is very simple. So what we will do? Back scattered radiation. So this, if we see what we see, if soil water content is more, as we have discussed, the dielectric constant will be more. Dielectric constant will be more. So that will reduce your backscattering radiation, or we can say emissivity. We can say emissivity. In E, this will be reduced. So more the water content, less will be the emissivity. That way we can measure the soil water content. Very simple. If you see in mathematical terms, your emissivity, your backscattering, this is your backscattering radiation or wavelength. is function of, this is a function of or E, okay, and lambda, another one is your height, another one is your density, another one is your alpha, R, V. You can see this is a mathematical principle within the block. This E is for emissivity, okay, this is for wavelength, okay, the wavelength of radiation coming and going through, this is for lambda, and this phi is for incidence angle, okay. We will later discuss about Albert, how these radiations make angles. This is actually in terms of phi, this is Albert we can say, incidence radiation. This is the density of soil, this is your what, this is also one type of aspect angle, okay, and your R is your surface roughness, but our and this V is your volume of scattering, how much volume scattering is done, this is given by V. Our main aim is to know E, so we can say this back scattering radiation is directly proportional to your function of emissivity. The more the emissivity, the more will be the back scattering coefficient. The more the water content, the back scattering emissivity will be less. There will be less emissivity there. This is very simple. Now, I have forgotten to tell another thing. Why you choose them the microwave remote sensor? Because all those methods we have developed, they are used for very small areas. But in case of microwave remote sensing, we can say very large area is covered. Okay. Now, and the measurements are disadvantages. Major disadvantage is the measurements of soil water content is mainly to the surface, mainly on the surface of water. Okay, because we have radiations not going inside your soil, so the measurements of soil water content over a large area in a surface, only surface soil. Remember these points. And another important one is your tensiometer. This is very important. This is most commonly used for irrigation scheduling by our farmers. You see, you might have seen, okay, this instrument, there will be a porous cup, porous ceramic cup here. In this tube, this is a porous ceramic cup. Ceramic cup is there. Okay, the length of this may be 7.5 cm. This varies, and you see in this tube there is a vacuum gauge is attached, or in some tensiometers I have seen at Punjab and Haryana area, they will attach the indicators like your yellow, green, your red. When there will be green, yellow, red. If the water level in your green region, then no need to apply the water. If the reading now comes in your yellow region, then slight irrigation is required. You need to reduce to red region, then there is very deficient in water condition, or irrigation scheduling must be done this way. Okay, we'll discuss. We'll see how the irrigation scheduling is done based on this tensiometer. This actually measures your matrix suction. We have discussed suction or potential. Don't get confused with these terms. You see, there is also reading of like normally 15 cm. We did this mainly this reading type. How much deep this will be? Your instrument will be inserted. Okay, this type of markings are also done. What we do normally when we before inserting in soil for measuring the water potential or matrix suction, what we do, we will include or saturate overnight. Why this saturation is done? Because if there is some water bubbles, the vacuum reading will be, what is this? This is the full of vacuum. Okay, so this vacuum reading will be affected. So what we do before using previous slide, we will keep it in a bucket. We will saturate with water. Okay, carefully. We will now before taking, we will here use the cap so that no air enters. This is a full of saturated water. Okay, up to this point, you can say up to what point we are measuring that up to saturated with water. Now, when we measure we insert inside soil, there will be soil. If the water content is less, then water moves from higher energy state to lower energy state. That we have discussed already. So, from saturation to this perforated. These are all perforated and porous ceramic cup, the water will move out from your tensiometer and there will be creation of vacuum. The more the vacuum it creates, this reading will be done by your vacuum gauge. This is not very simple. As the water comes out from this, okay, because of higher energy to lower energy state, there will be creation of vacuum. This vacuum will be measured by your vacuum gauge. This is very simple principle. Okay, and remember another point, most important point. These readings actually most often limited up to, we can say as a 0.85 bar or 1 bar. We have already seen the field capacity moisture content is up to what? 0.3 bar and 0.1 bar. Okay, this is, I am writing this sum that I am not writing negative sign. If someone want to write it in potential terms, you can assign the negative sign. Very simple. This 0.3 and this can measure and your next moisture constant value, your permanent wilting point is your 15 bar. So we can see from field capacity to permanent wilting point, this can measure. This will only measure up to certain point, that is 0.85 bar or 1 bar, you can say. And this is mostly the readings are most suitable in case of sandy soil. Okay, the measurements are affected in clay soil and your organic soils. Okay, remember these memory type things. I think from this only it is very simple to understand. I have not confused you with more symbolic like here manometer, mercury manometer is used. There are many types of tensiometers available. We have just discussed here the very simple one. One I would say rather two types. One is your vacuum gauge, another with your indicators. Here it will be green, here will be yellow, another one will be red. So if the reading comes in vacuum comes this green region, then there will be no irrigation required. If comes in this yellow region, then there will be slight irrigation is required. And in red region, but now the soil is very deficient in water. This type of tensiometers are used. And if you see these are measured in field condition. If you want to measure your matrix suction at lab condition, we use normally pressure plate apparatus. The ceramic cups are used. All these things you can see from figure. I am not discussing the class regularly. Normally, you just remember we measure this matrix suction as lab condition. You use this pressure plate apparatus, and this is for matrix suction. If you want to measure the total water potential, soil water potential, we have discussed what is total soil water potential. You want to measure that. We normally use what? Thermocouple cyclometer. Thermocouple cyclometer. Just remember this point. Whoever will do PhD in this area, they will get used to these instruments and will know more principles. Normally in our exams, the principles are not